All right, ladies and gents, we're going to take a break from our normally scheduled programming to check out a product on the market that is somewhat a competitor to the LF Audio wireless volume controller. Doesn't that look kind of familiar? So here is the WVC Pro. Of course, here is the holder I designed. So, interesting. Almost seems like an exact copy, almost like somebody literally leaked my STL file, because I have handed it off to customers. Basically an absolute clone of my holder. All right. Very interesting. The WVC Pro also comes with this TPU case, which, as we could see, is nice, high quality with the strap. This guy comes with, interesting, the print lines are not aligned and it's thin. But let's keep going. Let's see what else we get here. Looks like we get a little charger cord with it. And again, the WVC Pro, I also provide a nice braided cord, which is pretty long. LF Audio cord here. There's a little generic cord you get. I guess, plastic. No, it's not plastic, super thin aluminum knob. All right, let me open this up. All right, so here's the unit, all 3D printed. I guess that's where the antenna goes. Here is the antenna itself. Looks like a generic antenna. I guess this is power and ground, so there's no remote line to turn it off remotely. And here's the actual knob itself. You can see. All right, 3D printed, and I guess you get one knob already installed. You get a replacement knob for some reason, and then I guess a little aluminum knob if you prefer that. And how do we turn the unit on? Looks like there's a hole for a strap. Here are the instructions. Wireless servo analog based system. It gives subwoofer volume without running RCA cables. Knob connects to the Wi-Fi showing real-time info on the OLED. Turn the knob, adjust the volume. Click once, perform selected action. Mute, step, deep sleep, NA. Long press, open the settings menu. Deep sleep, low power mode. Knob settings, comp mode. All right. I wonder who else has comp mode. Startup volume, volume after sleep. Find step and course step. I wonder who has that. Wake up, choose the wake up knob. Sleep timer, adjustable, dB scale, show volume in decibels, reverse rotation. I wonder who has all of that. Fallback volume if knob disconnects, VSET calibrate voltage reading, volt throttle, auto reduce volume when voltage is low. I wonder who has IDS. VTS brake, voltage when throttling begins. Pair device to the base, forget device. Up to 350 feet, line of sight, 1 to 2 weeks. Battery life, power draw, 2 watts. Voltage range, ooh, look at that. Works up to 18 volts. USB-C port charging, servo-based analog system, not chip-based volume control. This design keeps the sound pure and natural. All right, so we're going to test with the Quantz Asylum. All right, well, there we are. Turn it on, it says pair. So I don't know if that means that it's connected or not. Maybe we should go, let's see. Base settings and knob settings, again, very interesting. Let's do forget device. I guess it's paired already. When I did click it in, I did hear it. So I'm going to assume that it's currently working. If we disconnect and reconnect, so you could hear it on and off. All right. You could hear the servo. All right, let's connect it and do some tests on the quantisylum. All right, so there we are, 100% volume. There is the THD, whoa, there's the THD 0003. Incredibly quiet, no noise, again, because this is essentially an analog circuit. It has a potentiometer that is controlled by the servo. Really, really good SNR and THD. Again, it's all analog, so there's no electrical noise that could make its way through the circuit. You could actually hear it working. And there are the guts, which I have to say I'm actually incredibly shocked at what I'm seeing, because it explains the price. We have what looks like a hand soldered board. This is an ESP32 control module. These are about $5 to $10. We have a little servo motor. Usually you find these on like little RC airplanes or cars. And then you have a potentiometer, which is essentially a knob that you would find in a normal, RCA controller that you put in a handheld knob. So there's the power unit going to this guy. That explains why there's no remote functionality, because it's just using the onboard power of the chip. So you're relying on this guy. And there's the antenna connector. So if you have vibration, you could see things moving here, whether it comes to how long it lasts, especially in heat, because we're looking at a glue gun being used to make the connections. And as we know, in heat, these things get soft. So this is an incredibly effective way to make something like this as cheaply as possible, and it is one of the first designs I considered when I was thinking about making the wireless volume controller. Especially this part, which is using the potentiometer and control it mechanically. There is, again, two-sided connector here, so that's a simple way to feed power. And let's open this guy up. All right, very similar story. We have a battery. We have a PCB that seems to be hand soldered to an ESP32 module with an LCD. Pretty standard setup. So this is all off-the-shelf equipment. Looks like they put this here so there'd be no shorting between the boards, which is a little interesting. The knob, same thing, we just have a standard encoder, and it's all hand soldered, we could tell, on this 3D printer case with 1000 milliamp hour battery, 3.7 volt. So they're probably using the charging circuit. If we trace it off of the battery controller, some of these come with that. There's a battery protection circuit that they have built in. So yeah, the adage, you get what you pay for, is as true as ever. I don't have much to say, except that this is literally the cheapest way you could put something like this together. It's functional, it works, super cheap off-the-shelf hardware. There's no OTA, no Bluetooth, no high-precision digital devices, no custom circuits, no voltage isolation. So if you have transients on your car 12-volt bus, it makes it to the chip. If this guy gets warmed up into desert, or this plastic piece eventually wears out or fails. I mean, these are the drawbacks and why I mentioned that I never went with this type of design, because it's cheap, it works, but whether or not it actually lasts for any reasonable amount of time, I guess we'll find out. But I do just find the entire thing interesting, especially just how much is copied in both terminology and the design. So probably somebody got their hands on mine. They're like, hey, let me achieve something very similar functionality wise. And I say that with a grain of salt if you're talking about a very small portion of functionality. Cool. That's that. You probably want to see it as much as I did. And you can see it's already moving. You can see the motor in there because of the torque. And it's not fully aligned. As it rotates, it's already moving. So give it vibration, give it heat, give it time, and that motor will eventually likely come loose from that rear wall. And then it'll just sort of be spinning in the case. As you can see how much it has to turn. You see what I mean? Try and get a better angle of this. Yeah, you see it's already coming off the back wall. You could see the entire glue. Yeah. And everything is loose. And as this spins, it could spin into all these wires and catch on there too. So like almost no care was taken to try and like think about this product, the longevity of it.